So in this case, we are given the velocity time graph for a car that is initially moving to the north. So let's analyze this graph and describe the motion of this car. So if we look at the part AB, well, here we understand the car is moving at a constant or uniform acceleration to the north. Alternatively, you could have said the velocity of this car increases from 0 meters per second to 30 meters per second in 3 seconds. Or the third way you could have said the car is speeding up. But if we look at the part BC, well, here you can simply say the car is moving at a constant velocity to the north. But if we look at the part CD, you can tell them the car is moving at a constant acceleration in the opposite direction. So the car is still moving to the north, just that it's accelerating to the south. But if you don't want to say that, you can simply say the velocity of this car decreases from 30 meters per second to 0 meters per second in 2 seconds. That's what you can say. Right. But for the part DE, you can say the velocity increases from 0 meters per second to 20 meters per second. So the negative sign here, it shows you that the direction has been changed. It's no longer moving to the north, it's now moving to the south. And I want you to understand that for both of these two parts, the acceleration is negative. So they're actually accelerating in the opposite direction. But the difference is that for the part CD, the acceleration in the opposite direction means the car is slowing down. However, for the part DE, it means the car is speeding up. But of course, it has changed the direction. Fine. Sorry for so many words. I just want you to understand. Awesome. So let's go to the actual questions. Now, the first question says, write down the speed of the car at t equals 9 seconds. Well, when the time is 9 seconds, we can see that the speed is actually 0 meters per second. And then they say, write down the direction of motion of the car after 9 seconds, meaning for the part DE. So you tell them it's to the south. And then they say, write down the magnitude of the acceleration of the car during the interval 3 seconds to 7 seconds. So remember we said it's moving at a constant velocity. Every time you hear the word constant velocity, it means the magnitude of the acceleration is 0 meters per second squared. Right. Now it's time to get to the juicy questions. So here they say, without the use of equations of motion, firstly calculate the magnitude of the acceleration of the car during the first 3 seconds. So here you had to know that the gradient of a velocity time graph is actually the acceleration. But we know that gradient is change in y over change in x. So since on your y-axis you have velocity, you'll say change in v. And since on your x-axis you have time, you'll just say change in t. Then you say the final velocity is 30, initial is 0, the final time is 3, initial is 0. So your gradient will be 10 meters per second squared. Therefore, your acceleration is 10 meters per second squared. You don't give direction because they said the magnitude. Fine stuff. And then the last question says, calculate the total displacement of the car. So without using the equation, so remember we said the area under the graph of a velocity time graph will give you the displacement. Now, in order for us to find the area under this curve, we can see that it's going to be this region, that region, this region, as well as that region. But now, if you look at the last region, you can see that it's below the time axis. So since it's below the time axis, it means the area will be negative. Very key. Fine. So let's go to the part AB. So how do we find the area of that region? Well, it's a right-angled triangle, so it's half base by height. But for the part BC, it's a rectangle, so you say length by breadth. For the part CD, it's a right-angled triangle, so you say half base by height. And then DE, we said it's a right-angled triangle, but it's below the time axis. So the area has to be negative. Then you say the base of the first triangle will just be 3. And then the height of it will be 30 meters per second. Then you say the length of the rectangle is 7 seconds minus 3 seconds, which is 4 seconds. And then you say the breadth or the width will just be 30 meters per second. The base of this one will just be 2 seconds, and then the height will also be 30. And then you say minus the base of this one, it's just going to be 1 second, and then the height will be 20. So we don't say negative 20, it's just 20 because the height is a positive number. Very key. Right. Now, if you say 3 times 30, you get 90. 90 times a half, it's 45. Then you say 4 times 30 will just be 120. 4 times 3, it's 12. Yes. Then you say 2 times 3, it's 60. Divided by 2 will just be 30. And then you say 20 divided by 2 will just be 10. So if you say 120 plus 30, you get 150. 150 minus 10, it's 140. Then 140 plus 45 will just be 185 meters. This is the area under the graph. Then you conclude and say, therefore, the total displacement will just be 185 meters, like that. But what if the question said, calculate the total distance? How will it be different? If they ask you to find the total distance, the only difference would be instead of subtracting the area that is below the time axis, you are actually going to add it. Do you see that? So the total distance will just be 195 meters. Because for distance, we don't consider direction, but displacement, we do. Yes, So that is the difference. And this should be it for this video. Thank you so much for watching. I really hope it helps a lot. So in case you haven't hit the subscription button, please do the thing. Otherwise, keep safe. Let's see you in the next video.